There is a quiet hum to the cosmos, a predictable rhythm that we have learned to map and to measure with our instruments. We have charted the grand dance of galaxies, the slow waltz of planets, and the ancient light from the dawn of time. Our equations describe the universe with stunning precision, building a cathedral of understanding that seems both vast and wonderfully complete. We have grown comfortable within these cosmic laws, believing we have glimpsed the fundamental machinery of all that is and ever will be. But in the deepest silence of space, and the subtle noise between our data points, something new is beginning to stir. It is a whisper at first, a tiny discrepancy in our measurements that should not exist according to our perfect models. We see galaxies moving a little too fast, and the expansion of everything accelerating in ways we did not fully predict. These are not mistakes in our calculations, but rather persistent anomalies, like a single note played out of key in a grand symphony. We call these mysteries by placeholder names, like dark matter and dark energy, elegant confessions of our own profound ignorance. For decades, we believed these were the final puzzles, the last pieces we needed to find to complete the magnificent picture. But what if these are not the final puzzles, but are instead the first signs of a much deeper, more fundamental reality? What if the universe is not just hiding a few secrets, but is preparing to reveal an entirely new chapter of its story? The question begins to form in the quietest corners of astronomy, a question that is both thrilling and deeply unsettling. Is the cosmos we thought we knew merely a prelude, a simple introduction to a reality far stranger than we can imagine? Our most powerful telescopes, our eyes on the void, are now gathering light that hints at this unexpected and profound shift. We are detecting structures that are too large, and galaxies that formed too early, challenging our timelines of cosmic history. Every new piece of data seems to add not to our certainty, but to the weight of a great, impending surprise. It feels as if we are standing on a shoreline, watching the tide recede much farther than it ever has before. We all know that such a strange calm often comes just before the arrival of a wave of unimaginable size. This is the feeling that permeates modern physics, a sense that our foundation of knowledge is beginning to feel like sand. The standard model of particle physics, our great achievement, is beautiful and powerful, but it leaves so much unexplained. It does not account for gravity, nor does it tell us why there is so much more matter than antimatter. It is a brilliant map of a single island in what we are now beginning to realize is a vast, uncharted ocean. And now, from that ocean, we are starting to see ripples, evidence of things that our map cannot possibly contain. The universe, it seems, is not a static book to be read, but a living story that is still being written. And we may have reached the point where the author is about to introduce a completely unexpected turn in the plot. This potential revelation is not about finding a new planet or a distant star, it is about something far more fundamental. It concerns the very nature of reality itself, the rules we thought were unbreakable, and the substance of our existence. The upcoming surprise might be a new force of nature, hiding in plain sight, subtly shaping the cosmos around us. Or it could be a new particle, an exotic entity that passes through our world and our bodies without interaction. A ghost in the machine of the universe, whose presence is only now being inferred from its faint gravitational shadow. We are like detectives who have examined a crime scene for a century, only to find a single impossible footprint. This single clue threatens to unravel everything we thought we knew about the sequence of cosmic events. Our confidence is slowly being replaced by a state of profound and meditative wonder, an openness to the impossible. We are letting go of our rigid theories and learning to listen again to the deep, silent music of space. The data flowing in from our instruments is like a message in a bottle, written in a language we do not yet understand. But we can feel its importance, its weight, the sheer significance of what it is trying to tell us about everything. The next great discovery may not come with a sudden flash, but as a slow dawn of a new kind of understanding. A reality where space and time are not fundamental, but are instead emergent properties of a deeper, stranger layer. The universe might be showing us that our entire perception of three dimensions is just a shadow of a higher truth, We are on the verge of either a grand confirmation of our theories or a complete and total intellectual revolution. The quiet tension in the scientific community is palpable, a shared awareness that we are approaching a monumental threshold. Every physicist, every astronomer feels this subtle vibration, this sense of cosmic anticipation for what comes next. Perhaps the greatest mystery is not what lies in the darkness between the stars, but what lies hidden in the light itself. The very photons that travel for billions of years to reach us may carry information about laws of physics we have yet to dream of. We are sifting through the echoes of the Big Bang, looking for the telltale signs of a different, earlier universe. The surprise could be that our universe is not unique, but one of countless bubbles in a vast, unknowable multiverse. This possibility transforms our place in the cosmos from a central stage to a single grain of sand on an infinite beach. So we watch and we listen with a newfound humility, ready for the universe to once again reveal its true, unimaginable scale. We stand at the precipice of the unknown, calmly awaiting the next grand surprise from the silent, thinking depths of the cosmos. This sense of impending revelation is crystallized in what astronomers call the Hubble Tension, a subtle but persistent disagreement in our measurement of the universe's expansion. One method, using the ancient light of the cosmic microwave background, gives us one number, while another method, using the light from pulsating stars in nearby galaxies, gives us another. These two pillars of cosmology, which should agree perfectly, are locked in a quiet mathematical battle, suggesting a fundamental flaw in our understanding of cosmic evolution or the presence of a new, undiscovered physics influencing the fabric of spacetime. Beyond this cosmic measurement dilemma, there are anomalies etched into the very blueprint of creation, the cosmic microwave background itself. The infamous cold spot is a region of space that is inexplicably colder and larger than our standard models of the Big Bang can possibly allow. It is a profound statistical anomaly, a smudge on the otherwise perfect picture of the early universe. Some theories posit it could be the gravitational bruise left by a collision with another bubble universe, a tangible piece of evidence for a multiverse just beyond the veil of our own reality. Our search for dark matter, the invisible scaffolding that holds our galaxies together, has yielded decades of frustrating silence. We have built extraordinarily sensitive detectors deep underground, shielded from all cosmic noise, waiting for a single phantom particle to bump into our instruments. This lack of detection is becoming a mystery in itself, forcing physicists to consider more exotic and radical possibilities. Perhaps dark matter is not a particle at all, but a modification to gravity itself over vast distances, a sign that Einstein's brilliant theory is incomplete. The James Webb Space Telescope, our powerful new eye in the void, is compounding these mysteries with breathtaking observations. It is discovering galaxies that are far too massive and far too well-formed in the universe's infancy, challenging our established timelines for cosmic structure formation. These impossible early galaxies suggest that the process of star and galaxy birth was far more efficient and rapid than our models predicted, as if the universe was in a hurry to build the grand structures we see today, driven by processes we do not yet comprehend. This deluge of confusing data points towards a, quote, crisis in cosmology, a term used not with panic, but with a kind of restrained excitement. It signifies a turning point, a moment in scientific history where the old framework is no longer sufficient to contain the new reality being observed. Such crises are the fertile ground from which scientific revolutions grow, akin to the moments before Copernicus displaced the Earth from the center of the universe, or before Einstein reshaped our understanding of space, time, and gravity. We are living inside such a rare and transformative moment now. The surprise could manifest as a fifth force of nature, operating on a scale or in a manner that has so far eluded our detection. Our current model holds four fundamental forces: gravity, electromagnetism, and the strong and weak nuclear forces. A fifth force could be the missing link that explains the strange behavior of dark matter, or the accelerated expansion driven by dark energy. It might be a subtle field that permeates all of space, a gentle cosmic wind that only becomes apparent when you measure the movement of a billion galaxies. Another possibility is the existence of a dark sector of particles, a whole family of matter and forces that mirrors our own, but interacts with us only through the faintest whisper of gravity. This would mean that the universe we perceive, the one made of atoms and light, is only half of the story. Parallel to our existence could be an entire ecosystem of dark particles with their own dark chemistry and dark physics. A shadow cosmos whose presence is the great, invisible elephant in the room of our reality. The fabric of spacetime itself may not be the smooth, continuous sheet we imagine. At the smallest possible scales, the Planck length, quantum mechanics suggests that space and time should dissolve into a chaotic foam of possibilities. If we could zoom in to this fundamental level, our universe might resemble a roiling sea of quantum fluctuations. The new mystery could be that some large-scale cosmic phenomena we observe are actually macroscopic echoes of this deep, underlying quantum turbulence, connecting the infinitely small to the infinitely large. Let us consider the very constants of nature, the numbers that dictate the strength of gravity, the speed of light, and the charge of an electron. We have always assumed these are immutable, fixed for all time. But what if they are not? Some speculative theories suggest these constants could change subtly over cosmic eons, or even vary from one region of the universe to another. Finding evidence of this would shatter our conception of a uniform cosmos, suggesting the laws of physics themselves are not universal, but local bylaws of our particular cosmic neighborhood. The enigma of black holes also presents a path to new physics. According to our current theories, information that falls into a black hole is lost forever, a violation of the fundamental tenets of quantum mechanics. This is the black hole information paradox. The resolution to this paradox almost certainly requires a new theory that unifies quantum mechanics and general relativity, a theory of quantum gravity. The surprise might be that black holes are not endpoints, but are portals or gateways to something else entirely, their event horizons being the very edge of our known physics. Perhaps the most profound surprise would be the discovery that we are profoundly wrong about the nature of time. We perceive it as a linear flow from past to future, but in physics, this arrow of time is notoriously difficult to explain. The fundamental laws do not have a preference for one direction. The mystery could be that our experience of time is an emergent illusion, a product of cosmic entropy, or even a feature of our own consciousness. The universe itself might exist in a timeless block state where past, present, and future are equally real. Fast radio bursts, or FRBs, are another tantalizing piece of the puzzle. These are incredibly powerful, millisecond-long blasts of radio waves originating from deep space. While we have traced some to magnetars, many remain mysterious, with some even exhibiting a repeating, periodic pattern. Their immense power and short duration defy easy explanation, leading to a wide range of speculation. They are a constant reminder that the universe is filled with energetic, unexplained phenomena, cosmic lighthouses blinking at us from across an ocean of spacetime, signaling a physics we do not yet know. The potential for a paradigm shift is also altering how we search for extraterrestrial intelligence. We have traditionally looked for signals that resemble our own technology, but a truly advanced intelligence might not communicate with radio waves, but by manipulating spacetime itself, or by using the physics of a dark sector we cannot perceive. The great cosmic surprise could be that the universe is teeming with life and intelligence, but we have been functionally blind and deaf, lacking the theoretical framework to even recognize their existence. We must also confront the simulation hypothesis, which posits that our entire reality is a sophisticated, computer-generated construct. While seemingly philosophical, some physicists propose that this could be empirically tested. For example, if spacetime is a computed grid, there might be tiny glitches or resolution limits that we could detect in the behavior of high-energy cosmic rays. The ultimate surprise would not be a new law of physics within our universe, but the discovery that our universe is itself a piece of software running on an unimaginable cosmic hard drive. This era of mystery forces us to reconsider the role of consciousness in the cosmos. In quantum mechanics, the act of observation seems to influence the outcome of reality at the smallest scales. For decades, this has been treated as a strange quirk. But what if it is a clue? What if consciousness is not a random byproduct of biology on a single planet, but is a fundamental and integral component of the universe's operating system? The next great discovery might be the realization that the universe is not just something we observe, but something we are participating in creating. The discrepancy in the lithium content of the universe is another quiet anomaly. Our models of the Big Bang predict a certain primordial abundance of elements like hydrogen, helium, and lithium. While our observations for hydrogen and helium match the predictions perfectly, the observed amount of lithium is significantly lower than it should be. This cosmological lithium problem points to a gap in our knowledge of either the nuclear physics of the early universe or the subsequent life cycle of stars, a subtle but persistent error in our cosmic accounting. The strange, coherent motion of large galactic structures, known as dark flow, also challenges our assumptions. We observe vast clusters of galaxies moving in a uniform direction at extreme speeds, a motion that cannot be explained by the gravitational pull of any known matter in the observable universe. It is as if they are being pulled by something immense just over the cosmic horizon, a remnant structure from a pre-inflationary era, or the gravitational influence of a neighboring universe, a hint that our observable bubble is part of a much larger dynamic system. The very vacuum of space, which we once thought of as empty, is now understood to be a fizzing soup of virtual particles and to possess a certain level of energy. However, our best theory, quantum field theory, predicts a vacuum energy that is orders of magnitude greater than what we actually observe. This vacuum catastrophe is one of the most glaring failures in modern physics, a colossal disagreement between theory and observation. The solution will likely require a complete rethinking of how gravity and quantum mechanics interact at the most fundamental level. So we are left in a state of profound and beautiful uncertainty, an intellectual space where radical ideas can flourish once more. The rigid dogmas of the 20th century are slowly dissolving under the pressure of these new, inexplicable observations. This is not a failure, but a sign of a healthy and vibrant science. It is the necessary preamble to a breakthrough, the quiet before a conceptual storm, that will reshape our understanding of everything. The universe is not a problem to be solved, but a mystery to be continually deepened and appreciated. The impending surprise might be aesthetic as much as it is scientific. We have always sought symmetry and elegance in our physical laws, but perhaps the universe at its most fundamental level is not as neat as we would like. The ultimate reality could be a patchwork of different physical laws, a complex and somewhat arbitrary structure that just happens to give rise to the conditions we observe. The surprise would be that the cosmos is not a perfect crystal, but a messy, evolving, and far more interesting organism. The nature of neutrinos continues to offer hints of new physics. These ghostly particles pass through almost all matter, and we have recently discovered that they have a tiny amount of mass, which the standard model does not account for. Furthermore, there are hints of a fourth type of neutrino, a sterile neutrino, that does not interact with matter at all. The existence of such a particle would be the first major discovery beyond the standard model, opening a direct window into the hidden, dark sectors of reality. Think of the KIC 8,462,852 star, often called Tabby's star, which exhibits extreme and irregular dips in brightness that are difficult to explain with natural phenomena like transiting planets. While the leading theory now involves dust clouds, the initial excitement entertained the possibility of an alien megastructure, like a Dyson swarm. This star remains a powerful symbol of how the universe can present us with phenomena so strange that they temporarily break our models and force us to consider the most imaginative and outlandish possibilities, pushing the boundaries of what we deem possible. The fine-tuning of the universe itself remains a profound philosophical mystery. The fundamental constants of nature appear to be exquisitely balanced to allow for the existence of complex structures like stars, planets, and life. If gravity were slightly stronger, the universe would have collapsed back on itself. If slightly weaker, galaxies would never have formed. This could be a cosmic coincidence of unimaginable improbability, or it could be the strongest evidence yet that our universe is part of a vast multiverse, where we naturally find ourselves in one of the rare universes with life-permitting laws. The coming surprise could be a new understanding of information as a physical entity as fundamental as matter and energy. Some theories, like the holographic principle, suggest that all the information contained within a volume of space can be described by a theory on its boundary, as if our three-dimensional reality were a projection from a two-dimensional surface. This would mean that space-time itself is not fundamental, but an emergent property of quantum information being processed at a deeper level, a truly revolutionary concept for the nature of reality. As we peer deeper into space, we are also peering deeper into time, and the boundary of our vision is the cosmic horizon, the edge of the observable universe. We cannot see beyond it, as the light from those regions has not had time to reach us. The surprise could lie in what exists just beyond that veil. Is it simply more of the same, an endless expanse of galaxies? Or is it where our universe ends and something utterly different begins? Our cosmic ignorance is bounded by this horizon, a constant reminder of our limited perspective. The very existence of cosmic inflation, the theory that the universe underwent an exponential expansion in the first fraction of a second, is itself a placeholder for physics we do not understand. While it explains many features of our cosmos, we do not know what field or energy source drove it. Understanding the inflaton field could be the key to unlocking the physics of the very first moments of creation, and it might reveal that our Big Bang was not a singular beginning, but just one of many such events in an eternal, self-reproducing cosmos. The mystery of antimatter's absence is a cornerstone of our confusion. The Big Bang should have produced equal amounts of matter and antimatter, which would have then annihilated each other, leaving behind a universe of pure light. The fact that we exist, that matter survived, implies some subtle asymmetry in the laws of physics that favored matter over its mirror image. Finding the source of this baryon asymmetry is a primary goal of particle physics, and its discovery would point to new forces and interactions that operated in the universe's fiery birth. The potential for a phase transition of the vacuum itself is a more unsettling possibility. Our universe exists in a certain energy state, but it might not be the most stable one. It is possible that it is in a false vacuum state, and at any moment, a bubble of true vacuum could appear and expand at the speed of light, rewriting the laws of physics as it goes. This is a theoretical but not impossible scenario. The ultimate surprise would be the universe fundamentally changing its own operating system without any warning. Our planetary science missions are also uncovering profound surprises closer to home. The discovery of subsurface oceans on moons like Europa and Enceladus has radically expanded the potential for life within our own solar system. This suggests that the conditions for life might not be rare, but are a common feature of planetary systems. The grand cosmic surprise might not come from a distant galaxy, but from a robotic probe drilling through ice on a nearby moon and finding a completely separate genesis of life. Ultimately, this era of new mysteries is a gift. It prevents us from becoming complacent in our knowledge and reinfuses science with a sense of adventure and profound humility. It teaches us that the universe is not just a collection of facts to be memorized, but a dynamic and unfolding story in which we are both audience and participant. The expectation of surprise is the proper mindset for a species that has only just opened its eyes to the true vastness of the cosmic ocean. The phenomenon of gravitational waves, ripples in space-time itself, has given us a completely new sense with which to perceive the universe. We are no longer just looking at the cosmos. We are listening to it. We are hearing the collisions of black holes and neutron stars. This new field of multi-messenger astronomy combining light, gravitational waves, and particles is almost certain to reveal phenomena that were previously invisible to us, opening a new chapter of discovery and uncovering mysteries that our telescopes alone could never have solved. The strange alignment of certain features in the cosmic microwave background with our own solar system, dubbed the axis of evil, is a statistical anomaly that continues to perplex cosmologists. It suggests a possible, though highly improbable, correlation between the largest structures in the universe and the plane of our own small solar system. While likely a statistical fluke, it is a persistent anomaly that stubbornly resists easy explanation, forcing us to question the Copernican principle that we do not occupy a special place in the universe. The next great surprise may come from a source we are not even looking at yet. Throughout history, major breakthroughs have often come from unexpected directions, from scientists exploring phenomena that were considered niche or unimportant at the time. The universe is under no obligation to reveal its secrets in the areas we are most focused on. The key to dark energy might not be found in a telescope, but in a tabletop quantum experiment that reveals a subtle, previously unknown property of the vacuum. We should consider that the universe is not just strange, but that it might be fundamentally non-intuitive to the human mind, which evolved to understand the physics of a terrestrial environment. Our brains are not naturally equipped to grasp the realities of quantum superposition or 11-dimensional spacetime. The impending surprise might be the realization that we need new tools, perhaps augmented by artificial intelligence, to even formulate the correct questions to ask, let alone comprehend the answers that the cosmos is trying to give us. Even the nature of gravity remains deeply mysterious. We describe its effects with incredible precision, but we still do not know what it is. Is it a particle, the graviton? Is it an emergent thermodynamic property of spacetime, as some new theories suggest? Or is it something else entirely? Unlocking the true quantum nature of gravity will be the great achievement of 21st century physics, and it will undoubtedly lead to a cascade of revelations about the origin of the universe, the nature of black holes, and the ultimate fate of everything. The sheer complexity and interconnectedness of the cosmos, from the cosmic web of galaxies down to the quantum entanglement of particles, suggests a holistic nature that our reductionist science is only beginning to appreciate. The surprise might not be a single new particle or force, but a new principle of organization, a law of complexity that governs how systems evolve and create novelty. It could be that life is not an accident, but a natural and expected outcome of a universe that is fundamentally biased toward creating pockets of organized complexity. The very passage of time might be slowing down, according to some controversial studies of distant supernovae. While this is highly speculative, it highlights how even our most basic assumptions about the cosmos are being tested. If time itself is a dynamic quantity, it would revolutionize our entire model of reality. This is the kind of profound, foundational shift we may be on the cusp of, where the very stage upon which the cosmic drama unfolds is revealed to be an active and changing participant in the story. The quiet glow of intergalactic space, once thought to be perfectly dark, is now known to be filled with a faint light from rogue stars torn from their host galaxies. Studying this intercluster light gives us a new way to trace the effects of dark matter and the violent history of galaxy mergers. It is another example of how we are finding new information in places we previously considered to be empty, turning the voids into valuable sources of cosmic data and deepening the mystery of galactic evolution. What if the universe is, in some sense, alive? Not in a biological sense, but in the sense of a self-organizing system that learns and evolves its own physical laws over time. This concept of cosmological natural selection suggests that new universes are born from black holes, and their fundamental constants are slightly varied. Universes that are better at producing black holes, and thus more offspring, would become more common. Our universe's fine-tuning would then be a result of this cosmic evolution, not a random chance. As we stand here, at this unique moment in history, we are the universe's attempt to understand itself. The carbon in our bodies was forged in the hearts of dying stars, and the water in our cells is as ancient as the solar system. Our quest for knowledge is not an external activity, but a natural expression of the cosmos itself. The impending surprise, therefore, is not just something happening to us. It is a change within us, an expansion of our own cosmic consciousness, as we prepare for the next layer of reality to be revealed. We are building ever larger instruments to probe these mysteries. Colossal telescopes on remote mountains, vast particle accelerators buried underground, and sensitive detectors in space. These are our modern cathedrals, built not for worship, but for a profound and systematic form of wonder. They are designed to capture the faintest whispers from the cosmos, the subtle clues that will either confirm our current picture of reality or shatter it completely, paving the way for a new, more accurate, and undoubtedly stranger understanding of everything. Perhaps the final surprise will be a philosophical one. We seek a single, unified theory of everything. But what if one does not exist? What if reality is an endless onion, with a new layer of physical laws revealed at every new energy scale, continuing on infinitely? The end of physics may be an illusion. The journey of discovery might be the only destination, a perpetual unfolding of mystery that is the fundamental nature of existence itself. The universe may be constructed in such a way as to be endlessly interesting to any mind that evolves within it. The strange behavior of muons in recent particle accelerator experiments, like the muon G2 experiment, offers one of our most potent clues. These heavy cousins of the electron are wobbling in a magnetic field in a way that our standard model cannot explain. This deviation, though tiny, is statistically significant. and may be the first direct evidence of new, undiscovered particles or forces popping in and out of the quantum foam, subtly interacting with the muons and betraying their hidden existence. It is a crack in the edifice of our most successful theory. The accelerating expansion of the universe, driven by dark energy, points to a strange and lonely future. As galaxies are pushed farther apart, the sky will eventually grow dark, with all other galaxies receding beyond our cosmic horizon. This raises a profound question. Are we living in a special time, a brief cosmic era, where the universe is filled with light and information? Future civilizations may awaken into a universe that appears empty, with no evidence of the Big Bang or other galaxies, a possibility that reframes the preciousness of our current cosmic view. Let us return to the quiet of the night sky. For millennia, we have looked up and seen the same patterns, the same steady lights. But we now know that this apparent calm is an illusion. The sky is a riot of invisible activity. It is humming with the echoes of creation, ringing with the collision of black holes, and filled with the ghostly presence of a matter we cannot see. We are suspended in a dynamic, evolving, and deeply mysterious place that is only just beginning to tell us its true story. The next clue could come tomorrow, from a telescope's image or a physicist's equation, or it could take another century of patient searching. We cannot know the timescale, only that the evidence for a deeper reality is accumulating. The universe is challenging us, inviting us to abandon our old certainties and to embrace a new level of questioning. It is in this sustained state of not knowing, this calm and curious anticipation, that the true process of scientific discovery and personal wonder takes place. This is the nature of our cosmic journey. With every new discovery, the universe does not become smaller or more mundane. It becomes infinitely larger and more magical. Each answer we find gives rise to a dozen new and more profound questions. The surprise we are waiting for is not an endpoint, but another doorway, leading to an even grander hallway of mysteries, stretching on beyond what we can currently imagine. Our knowledge is an island, and the ocean of our ignorance is expanding with every new observation we make. The universe does not owe us simplicity. It does not need to conform to our aesthetic desires for elegance or our cognitive need for simple narratives. It is what it is, in all its bewildering complexity and magnificent strangeness. The surprise may be that we must let go of our desire to have a complete and final picture, and instead learn to live within the ongoing process of revelation, appreciating the beauty of the questions themselves and the privilege of being here to ask them. So as we drift through this quiet, thinking cosmos, we remain vigilant observers. We watch the steady light of ancient stars, knowing that any one of them could carry the signal that changes everything. We listen to the static of the void, knowing it contains the whispers of creation. We are explorers on the shore of an unknown sea, and the tide is pulling back, revealing a landscape that no human has ever seen before, filled with new and profound mysteries. The universe is about to surprise us, not with a sudden sound, but with a deepening silence, a quiet and profound realization that the map we have been using is only a single page from an infinite book. And the next page, filled with a physics and a reality we have yet to dream of, is just now, slowly, being turned. The sheer complexity and interconnectedness of the cosmos, from the cosmic web of galaxies down to the quantum entanglement of particles, suggests a holistic nature that our reductionist science is only beginning to appreciate. The surprise might not be a single new particle or force, but a new principle of organization, a law of complexity that governs how systems evolve and create novelty. It could be that life is not an accident, but a natural and expected outcome of a universe that is fundamentally biased toward creating pockets of organized complexity.